Hello, so we are back Monday morning, and it's like 10 minutes before 9 o'clock. I'm coming here first, like 20 past 8, after I drop the kids at school, and I'm alone. There's no one here. You know how cold it is? Outside is like -1 degrees and windy. Okay, we have a job. We have a nice laptop. Look, Nvidia i5 at 8 generation. And the problem with this one, this laptop came here with change charging port plus charger. But why you should change a charging port? I mean, the charging port is just fine. I don't think you can see it. What's the point replacing a good charging port? They didn't test it, so obviously they don't know, but if the laptop comes on, and the laptop comes on because I checked, but it's not charging. So we have on the power supply, we have 19. Ground. First check ground. You have ground. You can see the voltage is going down and the current. So we have, and the middle pin, is doing nothing. So on the middle pin is taking nothing, no power, but the charging port it is fine. Okay, so let's check. Let's open this quickly and test. What do you think Sorin did in the morning, like 7 o'clock in the morning? Like 7 o'clock outside. Yeah. I did. You remember I told you about the helium project. I'm still doing fine with the helium project. So I made a video in the morning. Was like -1 degrees even in the morning, like 7 o'clock. I replaced the antenna, yeah, with a McGill 9 decibel antenna, and basically everything just doubled, the income doubled, which I was like surprised. I was shocked, that's the reason why I made a video in the morning. Anyway, if you didn't follow the channel, which is dedicated to helium, nothing there with something else, yeah, you'll find on the link a link on the description of this video. But I was shocked. I was shocked even from when I tested, the gain. I was getting like 50 decibel gain, like the same like a Yagi antenna, which was crazy. I understand some people are not interested on this, but dealing with radio waves and antenna is another part of the electronics. I don't know. Personally, I'm exciting about anything related with the electronics. Well, let's see. Let's open this. Morning. Give me 1 second. 1 second. Yes. Okay, so we are doing good. Morning. Give me 1 second. Another customer. Okay, I'm trying to explain the customer. The shop is not yet open because everyone is coming like 9:30. Let's see what can be here if the charging port is good, but it's not charging. What can be here? I'm curious, same like you. Like what can cause It's not like only not charging. It's like not coming on with the charger. That means there is no voltage. It's not like a battery issue. No, the battery is still holding the charge. I can power up the laptop. So basically, it's still something related with the charging port or with the main power rail, which is missing, most likely. Oh, we have one more screw here. Now the problem is the people booking in these kind of jobs. They are looking at the laptop. Okay, it's not coming on, and they, oh, what should I choose this time? Charging port or motherboard repair? It's kind of that. Because obviously to check you have to open the laptop. It's a nice board. We have a dedicated graphic chip, which is nice. Okay, so let's open the hinge because here is the charging port and it's under the hinge. Let's see what's going on here. Why is not working? Okay, this screw is spinning by itself. So I suppose the hinge is broken here. Yeah, it is. You can see. Oh, the charging port looks fine, How this laptop is not charging? So check here the charging port is soldered properly on the board. So that's the charging port. And it is soldered. You know what we can check? We can check with the multimeter. Let's switch on the diode mode. The middle pin from the outside of the charging port, from here to here, yeah? So let's see, from here to here. Oh wait, it does ground? Yeah, it touched the ground, 1 second. 0, 0. So the charging port, it is fine. Like how I said, the charging port is fine. So what's the reason why it's not charging? Let's come with the power supply, 20 volts. Ground, plus. And it's taking no power, it's taking 0. You can see on the power supply is 0. What can be the problem here? I don't get it. I mean, from here it's going on the first Mosfet, the second Mosfet, then the current resistor, which I can't see them on this side of the board. You can see them. This is from charging. We have the current sensor there, the coil, the power supply. This is from the processor, but I can't see anything else. So I suppose it's on the other side of the board. Can be. Let's open the board and check. This is strange. It's a strange fault because the charging port, it is good, but it's taking like 0. It's not normal to be 0. Even if it's not charging, still, The battery is like, is holded by nothing. So look how cheap are those laptops from these days. Like, why will not fit us a screw on the battery? Because it has no screw holder. It's not fitted. I think they tried to make these things cheaper, so they didn't fit the, to screw the battery inside. That's insane. How much money you can save from 2 screws? And this is an expensive one, yeah? Remember, this has a dedicated graphic chip. It's not like, let's say, a cheap laptop. Okay, it's cheap because it's cheap. No. This is not cheap. Okay, we have an M2 drive here. Let's take the drive out. We have a BIOS battery. Good. Now the keyboard. I believe the fan. You know what I was thinking? I was thinking, you know what, the charging port, probably the middle pin is disordered on the board here inside, but it's not. It's a different fault. Now, if outside is like -1 degrees, here inside are like 10 degrees, because the shopping center is not heated. And I have a fan here next to me. But yeah, when it's cold, it's quite bad here. Anyway, they send us a note. They will demolish the building to build apartments. So at some point we have to move from here and a different place. Okay. So we can clearly see, I don't know what this diag is doing, probably the diode is on the parallel mode with the charging board, I have no idea. We can see the first MOSFET, the second MOSFET, the current resistor here. Yeah? Let's have a look under the microscope and see what these are doing. Let's see. Okay, so the diode, check here, the diode is on a parallel mode with the charging port. So the manufacturer can screw you if you use a different charger, yeah? That's plus, and it's taking no current at all. I touched the ground there. That's plus, yeah? Nothing. Let's go further. Then we have the first MOSFET. We plus here, and here we can see some. I guess it's taking some power. You hear the power supply clicking. Okay, let's go with 19 volts on the input and check with the multimeter to see where our power stop. Plus on the charging port. Okay, it's diode mode. Let's change from the diode mode. Volts. Okay, plus here. Let's see. And we have here 20 volts. You can see on the screen. Then we have here nothing. Yeah. Now what is important is to check the voltage on the gate. And on the gate we have nothing also. So if we have nothing on the gate, the voltage will not go through the MOSFET. Now let's get a multimeter, change on diode mode, and check those MOSFETs. So clearly the first is not shorted. But I seen on the different laptop, if the second MOSFET is shorted, it will not work. And the second MOSFET is not shorted, it's good. The gate is not shorted, so we are fine. What about this gate? Is shorted? No, it's not. So what's the reason why that MOSFET is not getting voltage on the gate? Morning, Ash! What happened with you? Like 9:06? So early? Huh? Okay. So what's the reason? What can be the reason? Everyone start coming at the job. Hey, morning. So what we are doing? We are trying to figure it out. What's the best way to find the fault? Probably the gate is coming from this chip, which can be dead. Or we are replacing our Mosfet with a proper calibrated fuse, which I think is the best what we can do here. That's the MOSFET, but the MOSFET is good, you know. It's not about the MOSFET, the gate voltage is missing. Okay. So let's see. Also, we can check the charging here. We have the power supply, so we can check. Let me get a fuse. People laughing about my proper calibrated fuse, but you guys came with this and years ago when I started doing it and say, "Ah, sorry, you replace it with a proper calibrated fuse." Yes, indeed, we did it. Someone used my solder iron to melt plastic. I can't believe. Yeah, that's what's happened when I'm not here. Okay, so we have this and we have this. Okay. And we have our fuse. Where is our fuse? So we replaced one type of protection. Yeah, because those MOSFETs are not doing anything else, just as protection here. We got different kind of protection. A fuse is a protection, yeah? Dodgy? Definitely. But working great. I can't see a reason why this it will not work. Okay, let's put the board back and check the charging, check everything. Everything is working fine and great. It's just a different design, yeah? So we redesigned the board. And if you are telling me again the manufacturer is the god, you know, I'll not believe it. So let's put a BIOS battery. Okay. And let's plug the battery. Sorry, let's plug the battery. Let's come with 19 volts because if it's not charging, it's a different story. But sure, charge fine, yeah. So let's see, ground plus. Sorry, current is too low. And it's charging great. No. Let me unplug the battery. Okay, I know why that MOSFET died. 19 is taking no power. And when we are connecting the battery, actually it's taking a lot. And the voltage is even going down to 18, yeah? That's the reason why that MOSFET is was not open. So just replacing by the fuse. Actually, it's not like it's charging. It's overcharging right now because the whole current goes on the battery. So what's the problem? Without checking, I can tell you what's the problem. This is the battery power supply. The battery charging circuit, yeah? Let me... Yeah, this is the battery charging circuit. It's a switching power supply. That's the plus as the current sensor, which is going to the plus of the battery. Yeah, here. You see the red wire? Now, the coil is driven by these two MOSFETs. If one MOSFET is shorted, like the high side MOSFET in our case, it will 19 volts, it will go straight to the battery. So we'll unplug the battery, we'll get the multimeter, diode mode, and the high side Mosfet should be this one, yeah? And the high side Mosfet is not shorted. It's not. Okay, that's mean our driver is dead and is keeping open the Mosfet all the time. You know how we can check? We can come with the power supply on the charging port. Let's come with the power supply on the charging port. No, the Mosfet what we remove is not regulating the voltage, yeah? Keep in mind, yeah? It's not doing this. No. This main power rail on this laptop is 19 volts. So no. So this is the multimeter and this is the power supply. Power supply, and let's check the voltage on the coil. Switch to voltage. And we have 1 volt on the coil. And here we have 19. Yeah. Yeah. I don't know, I have to check first. Okay. Yeah. Just leave it, I'll have a look and you'll get a phone call, yeah? You'll get a phone. I don't know. I have to check what's burned on that board. I'll give you a call before I fix it, yeah? Then come back later. Yeah. It's okay. Okay. So one more time. Okay, this is weird. So from some reason, anyway, all these problems are related together. Yeah. So the first MOSFET not working with this charging at full power. So it's nothing shorted here. Let me plug the battery. So I plug the battery. I will lower the current. Yeah, just a little bit. So 1.9 amps. So check the voltage here. So the voltage right now is 16 volts because the MOSFET is pushing voltage how much he can. So it's not regulating, this chip is not regulating the charging. You see? So it's pushing a lot of current in the battery right now because you can see the power supply is on limit. So the limit of the power supply is 1.9 amps, but the voltage dropped to 17 volts. And the voltage here is like 16.2, which is about the max voltage of the battery. So you see on a case like this, so what I suppose happened, you know what I think is happening? The power management chip doesn't get the signal from the charging circuit from the battery. Probably if it's no communication between these two chips, the power management chip, it will cut down the power by the first MOSFET. And it's doing right, because otherwise, like what I did, I replacing with a wire, is pushing a lot of current inside of the battery. So the battery can explode, can overcharge. Not, cannot explode, it can overcharge. Okay? Which is a bad thing. So you see, there's no limit right now there. I can push how much current I want with the power supply. So actually, that wire is a bad idea if we leave the laptop like this. So the issue here, you have the current sensor in the serial mode with the plus of the battery. The chip, he can't see the current, which is going to the battery, or he can see the current, but the chip is just dead. But it looks like he's switching. Maybe it's not switching. I don't think he's switching. No way. This is not switching. You know what I think is happening? The chip is gone, and it's just keeping open the high side Mosfet from the charging circuit. The solution here, replacing the chip. Yeah, and that's what I will do. I will order this chip because I don't have this chip. What chip is here? It's a BQ24780. We don't have something like that here. Huh? BQ. Oh, this one. You can see the battery slot and you can look around for a BQ chip. No, it's not the same, but I can check. BQ. Oh, that's something else. Maybe this one? No. Let's see on different boards. Maybe I can find one. No, this seems something else. No. 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 Possible I don't have that chip. BQ737 is different. Not what we need. You know what what I will do? I will stop the video. I will order the chip, and we will do like a second part. BQ737. Nah. No, nothing. I have nothing here. No. Okay. So I'll order the chip. The fault is kind of clear, you know, but it's a nice fault because because indeed what they assume it will happen, it works like it works great. So they how this was concepted, yeah. Okay, if the MOSFET goes shorted or the chip something wrong happen, which is happening in this case, okay, let's stop the power by switching off the first MOSFET. Exactly what happened. So those protection are indeed good. Yeah, it's not like a bad idea. Yeah, so I will feed back the first MOSFET, which is doing the job, what it's supposed to do, and I will order that chip. And I suppose I will see you on the second part of this video. Yeah? Great. Thank you for watching. Like and subscribe if you like the video. And see you on the next one. Bye.